Get ready to witness the 7 selected Chinese megalomanic projects, where China are rapidly changing the construction landscape and pushing boundaries with mega projects that leave engineers worldwide with their mouths open. Think about colossal dams that generate record-breaking amounts of electricity, wind farms as high as never built before, tunnels that are built through impossibly tricky terrain, and bridges that make you feel like you're walking on air. In China, these projects aren't only big, they're built super fast. They are using advanced technology and cutting-edge construction methods, and an unwavering determination fuels this relentless pace of growth. But how does China do it? And what secrets lie behind these engineering marvels? And what do American engineers think of it? Let's dive in and discover some of China's most insane megalomanic projects. The first project on our list, the ultra-high wind power farm in Tibet. In Nagku City, located in the high mountains of Tibet, a remarkable wind power project is developed. This project, standing at a breathtaking altitude of 15,000 feet or 4,500 meters, marks a significant achievement in China's renewable energy development, and it is the largest ultra-high wind power farm in the world. The wind farm consists of 25 turbines and has the capacity to generate 100 megawatts of power. This is enough electricity to sustainably power 230,000 residents every year, producing around 200 million kilowatt hours. By implementing this project, it is estimated to save 60,000 tons of coal and reduce carbon emissions by 160,000 tons annually. Despite the extreme altitude and challenging weather conditions, such as intense cold and strong winds, the project was completed in 2024 and took just over 260 days. The total investment was just above $90 million. The success of this project not only demonstrates the feasibility of large-scale renewable energy projects in harsh environments, but also sets a benchmark for future high-altitude wind power initiatives. This pioneering effort is part of China's broader strategy to embrace new energy sources, including wind and solar, alongside its traditional hydroelectric power. This initiative highlights again China's commitment to expanding its renewable energy footprint and leading in high-altitude wind power technology.
Comment from American engineer, Mr. McGowan. This is actually really interesting. The air pressure at such altitudes is so low that it takes a lot larger turbine to get the same amount of power compared to one at sea level. I'm impressed they were able to tackle this problem successfully. The flip side is being the insane energy potential from tidal, as water is so much more dense. But that comes with its own set of headaches. Great work. I am very impressed.
Number 2, the Juwai Mau Bridge. Spanning an impressive 34 miles or 55 kilometers, this bridge holds the title of the world's longest sea crossing. Featuring a trio of cable-stayed bridges, artificial islands, and among the longest underwater tunnels globally, the construction of this grand project spanned 8 years and cost more than $19 billion. Linking Hong Kong, the new Hong Kong International Airport, Macau, and Zhuhai, it significantly shortened travel times between the 11 cities in the area, showcasing the engineering power of China through this Kong-Zhuhai-Macau bridge. Nestled within the densely populated Pearl River Delta, home to approximately 68 million residents, the bridge symbolizes a critical connection point in one of the planet's most crowded regions. The late 20th century witnessed a surge in development for Hong Kong, creating a wave of new roadway expansions towards mainland China, particularly enhancing the Eastern Delta's connectivity. Yet, the West remained relatively isolated, with the quickest route being a lengthy 160-kilometer drive that took roughly 4-5 hours. The transition of Hong Kong and Macau from British and Portuguese control back to China in the late 1990s catalyzed discussions between Chinese and Hong Kong officials about the possibility of bridging the delta's eastern and western shores to foster economic growth and unity. Recognized for its potential to boost employment, reduced border congestion, and reduced carbon footprints, the project received the green light. However, the challenges of the typhoons, the humid weather, and the strong currents made it a challenging engineering project. Construction commenced in 2009 on the Chinese portion, extending 29.6 kilometers, incorporating 22.9 kilometers of elevated paths and 3 significant bridges, concluding with an artificial island that leads into a 7-kilometer-long submarine passage. This innovative bridge tunnel design facilitates the uninterrupted movement of roughly 4,000 vessels that navigate the delta daily. The total undertaking used more than 420,000 tons of steel and 30,000 cubic meters of concrete, initially slated for completion just before 2020. However, environmental apprehensions regarding the project's impact on local marine life, specifically dolphins, led to a delay, pushing the finish line to 2021, where it's now operational and used daily. In April 2024, the Hong Kong government registered over 19,000 inbound and outbound vehicles on the first Monday, marking a record high since its opening. Despite its celebration as a monumental engineering marvel, the project faced scrutiny over delays, budget overruns, and construction safety concerns. Controversy further escalated in 2020 with the arrest of lab technicians over falsified concrete strength reports. Subsequent tests by Hong Kong's Highways Department, however, affirmed the bridge's safety, verifying its resilience against significant natural disasters and impacts. The Sanan Bridge. Imagine one of the busiest highway bridges in Beijing with over 200,000 car movements a day. The bridge is in very bad shape, and the city engineer gets the task to replace the bridge in the shortest amount of time. Because this bridge is the pinnacle of all the traffic in Beijing, and closing this road too long will be an economic catastrophe. We are talking about the Sanan Bridge in Beijing that got replaced. In this video, we will explain to you how the Chinese replaced the bridge in record time. CCTV just released a time-lapse video of the replacement of the bridge, which took only 43 hours. The aim was to complete the task in 24 hours, but the workers discovered that the damage was much worse than they had expected. German and American engineers were blown away by the Chinese quickness. Let's deep dive into how they did it. At 6 in the morning, they completely shut down the bridge. All the machinery was positioned in the night before, so all the cranes, bulldozers, and trucks were in position within 30 minutes. The old bridge has to come down, and fast. The first order of business: cut it into pieces. Big water-cooled round saws slice through concrete and steel, breaking the old bridge into 27 giant chunks. The heaviest weighs about 139 tons, which is the weight of 20 elephants combined. While this demolition of the old bridge is happening, the new bridge is nearby, massive, nearly 1,300 tons, fully assembled. How do you move something so big into its right position? Please meet the Shentuo, 2 monstrous Chinese-made transporters. These megalifters have 96 wheels each and can lift insane amounts of weight. See, these machines are linked by GPS and synchronized perfectly. They lift the new bridge a few centimeters and start moving it towards the old bridge, where the deconstruct team is removing the last chunks. To make it a speedy replacement, the engineers decided to keep the old supports and position the new bridge on top of it. The margin of error, millimeters. They used GPS, lasers, and the whole 9 yards. It's an engineering marvel in real time. Slowly, with agonizing precision, the new bridge slots into place. And get this, from start to finish, the entire process takes 43 hours, less than 2 days. Beijing's traffic nightmare is luckily averted. The original plan was that it took less than 24 hours, but all of the old support pillars needed new steel pins to support the new bridge. As the engineers couldn't see these pins before the demolition started, they ran into this unexpected delay. However, this project was completed within 43 hours, which is still mega fast. This project is a masterclass in megalomaniac thinking, high speed, innovation, brute force, and the sheer audacity of Chinese engineering. It makes you wonder what other mind-blowing projects are just waiting to be unveiled. Stay tuned to find out. The Baton Hydropower Station. Imagine a structure so big, it dwarfs the famous Hoover Dam not by double, but over 15 times in energy production. It took only 50 months to build, but in January 2023, the Baton Hydropower Station was fully connected to China's electricity grid. With an installed capacity of 16,000 megawatts, the plant is the last link in China's clean energy corridor, in a series of 6 megalomaniac hydroelectric dams built along the Yangtze River. This isn't just any concrete powerhouse. It's a statement of human ingenuity and a leap towards a sustainable energy source. But how did experts tackle the mammoth task of preventing thermal cracks, a common enemy in such giant builds? Stay tuned as we unveil the engineering marvel that is set to revolutionize power generation. Standing at a breathtaking 1,000 feet or 289 meters, the construction of this concrete giant involved over 8 million cubic meters of specially designed cement concrete. Mixed by a team of Chinese engineers, this material was the key to outsmarting the natural adversary of temperature-induced cracks. But the dam's sheer physicality isn't its only boast. With an installed capacity of 16 million kilowatts, it's set to produce over 62 billion kilowatt hours of electricity annually. To put this into perspective, that's more than 15 times the energy output of the Hoover Dam, marking a monumental step in reducing China's carbon footprint by over 51 million tons. And to make this even more relatable, the Hoover Dam can support around 1,250 homes annually with the electricity that it produces. The biggest dam in China can support around 20,000 homes per year. The Baton Hydropower Station is nestled at the heart of the Yangtze River. It's not just a power generator, it's the backbone of the West-East Power Transmission Project, aiming to even out the power supply discrepancies across China. As this dam is the second largest in terms of installed capacity, only behind the Three Gorges Dam, this engineering marvel is more than a static giant. It's a dynamic force in flood and sediment control and plays a vital role in improving the nation's navigation channels. Now let's go from a very fast building project to a project that could only move around 2 or 3 meters a day. The Humaling Tunnel. What do you do when every expert in the world tells you this tunnel project is impossible? When it's only a tunnel of 173 meters or 550 feet. That's what everybody said about the Humaling Tunnel, a megalomaniac project of engineering where impossibility meets ingenuity. The Humaling Tunnel in Gansu Province is one of the many tunnels of the Lanwu Railway. Originally dismissed as the most challenging tunnel ever proposed, it baffled engineers worldwide. Even German engineers, with its storied engineering tradition, admitted defeat. Why was this tunnel, which is only 173 meters long, the most difficult to build? Let's find out. All the engineers on this project knew that every shovelful of soil could mean collapsing and disaster. This train tunnel wasn't slicing through inert rock. It was digging through a living landscape of waterlogged sand, a soil so creamy it was almost comparable with quicksand. The proposed location of the tunnel was intersecting a reservoir and a river, which meant the surrounding earth was very saturated. Every dig risked collapse, and heavy rains only heightened the threat, turning construction into a gamble with nature itself. One veteran engineer remarked, "Each day felt like a silent standoff with the earth itself, waiting to see if our next move would be our last." Despite global skepticism, China was, as always, determined to make it a success. A revolutionary approach was required. Ingenious minds converged to devise a solution, implementing a mix of different strategies, a step-by-step excavation method complemented by vacuum dewatering techniques to stabilize the treacherous soil. Over 6 years, a dedicated team of 1,200 labored tirelessly, advancing at a painstaking rate of only 2 to 3 meters a day. They battled not only the unstable ground but the severe climate, with teams dedicated solely to breaking through ice in the winter to prevent the work from stalling. The completion of the Humaling Tunnel was more than an engineering victory. It was a symbol of human tenacity. Filling a critical gap in the Lan-Wu Railway, its completion has not only bolstered regional trade, but also stands as a beacon of what can be achieved when human spirit and ingenuity unite. If you're inspired by this incredible story of determination and innovation, hit that like button and subscribe for more amazing engineering stories. Now on to the next, the biggest dam of all. The Three Gorges Dam. This is the biggest dam in the world. But take a look at the latest satellite photos. The dam is not anymore the exact shape as it was designed. Little cracks in the concrete of the Three Gorges Dam show that the build of it was rushed. Currently, 2 teams of engineers are investigating if the biggest dam in the world can break. How could this happen? And how is the dam built? Let's deep dive the biggest dam in the world. You can find Three Gorges Dam on the Yangtze River in the Hubei province in China. When construction of the dam officially began in early 2000, it was the largest engineering project in China. At the time of its completion in 2006, it was the largest dam structure in the world. The dam and accompanying hydroelectric plant were built in phases and over several years. It reached its full generating capacity in 2012, and the dam allows the continuation of ocean-going vessels and generates hydroelectric power. This dam is nothing short of colossal. It spans a mind-boggling 2,335 meters or 7,600 feet across the river and towers 185 meters or 600 feet high. To create this behemoth, engineers used a staggering 28 million cubic meters of concrete, enough to fill thousands of Olympic pools, and integrated 463,000 metric tons of steel into its monolithic structure. But the Three Gorges Dam isn't just about size. It's about reshaping a landscape to unlock the river's potential. The dam's construction flooded the 3 scenic gorges, creating a vast reservoir that stretches 600 kilometers upstream. This new deep-water highway allows massive ocean-going freighters to sail over 2,000 kilometers inland from the East China Sea all the way to the bustling city of Chongqing. Think of the logistics required to navigate this massive dam. Engineers designed a series of ship locks capable of lifting and lowering the biggest vessels. For smaller ships seeking faster transit, there's an even more incredible feat of engineering: the world's largest ship lift. This colossal elevator for boats bypasses the locks, ensuring swift passage past the dam in less than 30 minutes. The heart of the Three Gorges Dam lies in its power generation. Deep within its massive structure, 32 powerful turbine generators spin with the force of the Yangtze, turning the river's flow into electricity. These turbines make the Three Gorges Dam the most productive hydroelectric power station on Earth. In 2020, it generated a record-breaking 111.88 terawatt-hours of electricity, enough to power millions of homes and fuel China's relentless growth. The Three Gorges Dam was also built to provide a vital defense against the devastating floods that historically plagued the Yangtze Basin. Construction on a project of this scale was an epic undertaking. It involved displacing communities, excavating over 100 million cubic meters of earth and rock, and pouring millions upon millions of cubic meters of concrete. This colossal construction site buzzed with thousands of workers, a testament to the sheer human effort and engineering feats required to tame a river and transform a landscape. Imagine standing 1,000 feet or 300 meters or above a breathtaking canyon, the ground beneath you made entirely of glass. The question is, would you dare to cross this bridge? This is China's Zhangjiajie Glass Bridge, the world's longest and highest glass-bottom pedestrian bridge. This bridge pushes the boundaries of construction and perception, creating an illusion of weightlessness that you will love or absolutely hate. This bridge isn't just about grandeur, it's an innovation statement. Supported by massive steel girders and weighing a reassuring 2,200 tons, it showcases the balance between aesthetic beauty and unyielding strength. And with a construction budget of 70 million USD, no expense was spared to ensure its integrity. But here's where it gets interesting. The bridge's glass deck, a tri-layer of specially hardened glass, each layer 50 mm thick, can withstand even a 40-ton truck driving over it. The engineers even proved it by driving a truck on it. Imagine that, only a 2 centimeters deflection and not a crack more. They even invited people to smash the glass with hammers. While the top layer shattered as expected, the crucial bottom layers remained intact, an undeniable testament to the bridge's strength. Dealing with high altitudes brought its own set of challenges, from wind forces to the potential for vibrations. Ingenious solutions, from discrete steel poles to giant glass balls and massive water reservoirs, were implemented to ensure stability and safety. Even the design incorporates bends in the railings to prevent the kind of resonant vibrations that can be so destabilizing. But the Zhangjiajie Glass Bridge is more than a glass bridge. It's also a venue for the adrenaline junkies. You can go bungee jumping off its platform as it adds another adrenaline rush next to this, the already heart-stopping experience. So, would you dare to take that walk? Let us know in the comments below, and don't forget to subscribe for more incredible stories of engineering marvels around the world.